Good morning. Today we're going to start talking about Chapter 8, which is entitled Quadratic Equations, Functions, and Inequalities. I'm going to abbreviate that title. Chapter 8, I'm just going to call it Quadratic Equations. Now, quadratic is a fancy name for degree 2 equations, which we've seen plenty of in the chapter on factoring. So when you think quadratic, think degree 2 equations. For example, 4x squared minus 7x minus 2 equals 0. That is a degree 2 equation. Alright, basically we've got two, actually up to now, we only have one way to solve this equation, and that's by factoring. There's another way via what we call the quadratic formula, and I'm going to introduce that to you today. Section 8.2 is entitled Quadratic Formula. Now the goal of the quadratic formula is clear. It's to solve degree 2 equations, or quadratic equations. Alright, so the quadratic formula, they've been beating into your head since 7th grade or so, I'm sure. Well, it says this. It says if, and this is a big if you've got a degree 2 equation in standard form, in other words, terms arranged in decreasing degree equaling 0, well, if that's true, then you can actually write down the solutions for x according to this somewhat simple formula, and this will probably look painfully familiar to you. X equals minus b plus or minus the square root of b squared minus 4ac all over 2a. Alright, basically what this is, it's another way to solve degree 2 equations. Alright, I'm betting you've done this once, twice, or even 100 times before in your math careers. So let's jump right in, work out some examples. I'm going to give you a degree 2 equation which I would like us to solve. 4x squared minus 7x minus 2 equals 0. Well, we can do it two ways. We can solve by factoring, or we can solve it by the quadratic formula. Well, let me try it by factoring. Let's see, it's already in standard form, so can I factor this equation? Let's see. I think I see something here. 4x and x in the first slots. Yeah, if I have a 2 and a 1, I can fool around with the signs to get the outer product of 8x and the inner product of 1x to add up to a minus 7x. If I get a minus 2 and a plus 1, I think that works just fine. Alright, so I'll branch this off to 2 degree 1 equations, 4x plus 1 equals 0, or x minus 2 equals 0, and I'll get the solution x equals negative 1/4, or x equals positive 2. So 2 solutions for x in this degree 2 equation. And alright, so that's by factoring. How about by the quadratic formula? Alright, it's already in standard form, and what I like to do is write down explicitly my values of a, b, be careful of the signs, and c before I stuff them into the quadratic formula. So x equals minus b plus or minus the square root of b squared minus 4 times a times c. Again, be careful of the signs when you're substituting in negative values, divided by 2a. Alright, looks good. Let me simplify this. On the right-hand branch, I get 7 plus or minus, what's under the root sign? Minus 7 squared is 49. Negative 4 times negative 2 is positive 32. And if I add those, I get 81 under that root sign over 8 is my denominator. Alright, of course, the square root of 81 is 9, so I get x equals 7 plus or minus 9 over 8. Now, plus or minus means just that. You've got the plus or minus option, which will typically result in two solutions in this degree 2 equations. So let me take the plus option first. 9 plus 7 is 16. 16 over 8 is positive 2. Or 7 minus 9 is negative 2. And negative 2 over 8 is equivalent to negative 1/4. Notice I get the same two solutions as I got by factoring. Alright, so quadratic formula is a valid way to solve degree 2 equations. Well, why not use it, why not use factoring all the time? Well, factoring, let me write it this way, not every polynomial factors. There are some prime polynomials that you can't break down into factors, hence you cannot solve by factoring. Right? So if you've got a prime polynomial expression, you cannot solve by factoring. You just won't factor. All right? In that case, you want to use the quadratic formula. Okay? All right, let's see another example. Let's see, solve another degree 2 equation. All right, I want to solve this, but the first thing you want to do is, well, let's see. I'm going to say solve by the quadratic formula. Let me specify. Turns out it doesn't factor, so I'll save you trying. Right, if you're going to use the quadratic formula, your equation has to be in standard form. So that's going to be my first step here, if necessary, to get your equation in standard form. Alright, let me write down A is positive 3, B is negative 2, C is negative 3 in this degree 2 equation. So x equals minus b plus or minus the square root of b squared. Be careful about the signs. Minus 4 times A times C all over 2 times A. All right. Notice everywhere I substitute a negative number in, I wrap it in parentheses so I don't mistake the negation for a subtraction, right? Minus 2 is 2, plus or minus, what's under the root sign? Minus 2 squared is 4. Minus 4 times 3 times minus 3. That will give me, let's see, 3 times 3 is 36. I get a 40 under the root sign, right? So 2 plus or minus the square root of 40 over 2 times 3 is 6. Alright, now we got to be a little bit careful about simplifying here. We're not quite done. You cannot cancel the 2 out with the 6. Let me kind of stress that. A lot of students will try this. They'll say 2 goes into 6 3 times, but you cannot do that. Let me put a no here because the 2 upstairs is a term of a sum. So you can't make cancellations in that fashion when you're involving terms of sums. So, well, what can we do? Well, we can simplify this root here first. Let me go back to yellow. X equals 2 plus or minus, well, the square root of 40 simplifies as 2 times the square root of 10 if I put that in simplified radical form. Alright, now the 2, again the 2's in the numerator, you can't cancel them with the 6, at least not directly, because you've got this sum in between them. Right? You cannot cancel out terms of a sum across a fraction bar. So what can we do? Well, what I can do is certainly recognize that 2 is a common factor in the numerator. And yes, now that this is a product, I can cancel out 2 goes into 6 3 times and get the final result 1 plus or minus square root of 10 over 3. Right, this represents 2 solutions. We could get decimal approximations if we use our calculator to approximate the square root of 10. But I say this answer is fine. Again, this is what I call my answer in simplified radical form, or what I like to say, simplified root form. Okay, 1 plus square root of 10 over 3, or 1 minus square root of 10 over 3. All right, let me do another example. Get a fresh screen here. Let's see, solve. Solve. Something happened there. How about something like this? A little harder. 4x equals 2x squared plus 1. Solve, and again, I'll save you looking. It will not factor, so we have to use the quadratic formula. Get it in standard form first. And what I always like to do is get a positive lead coefficient. I think that will always make your life easier here. So let me subtract 4x from both sides, and I'll get the resulting degree 2 equation, 2x squared minus 4x plus 1. Alright, so A is 2, B is negative 4, C is positive 1. So I'll go ahead and make my substitutions. X equals minus B, be careful with those signs, plus or minus the square root of B squared minus 4 times A times C all over 2 times A. Alright, a couple things I want to mention. Be sure that this square root sign swallows up everything it's supposed to. Notice I kind of exaggerate that with a closure mark on the end. Also be sure this fraction bar swallows up that entire numerator. And if you mistakenly put something outside of this division process, you're going to get a wrong answer. Alright, so let's go ahead and simplify now. X equals 4 plus or minus the square root. Minus 4 squared is positive 16. Minus 4 times 2 is 8, so I've got an 8 under that root sign. All over 2 times 2 is 4. Again, let me stress this. It's such a common mistake. A lot of students will try this. Hopefully it won't be you. They'll see the 4's and they'll try to cancel out these 4's. No, you cannot cancel out terms of a sum. You can only cancel out factors of a product, and that's not a product in the numerator. So let me delete that erroneous layer and try again. Hang on, need some more room here. Alright, well, if I can't cancel out these 4's, what can I do? I can simplify this root, and let's take a look at what happens when I do that. 4 plus or minus, well, the square root of 8 is equivalent to 2 times the square root of 2, is it not? Right, a 4 inside, a factor of 4 inside turns into a factor of 2 outside. Alright, and what I can do, well, I can't cancel out the 4's still, but I can see a common factor of 2 in that numerator. And then if I've got factors of a product across a fraction bar, yes, I can cancel out. 2 goes into twice. 2 goes into 4 twice. So my final answer is now 2 plus or minus the square root of 2 over 2. I know it's so tempting for students at this point. They've done everything right, and they'll start hacking those 2's across the fraction bar. But no, this is your final answer. 2 plus square root of 2 over 2, or 2 minus square root of 2 over 2. You can get a decimal approximation if you wish, but I usually ask for the answers in simplified root form. Okay. Alright, let's go on to another example here. Oops. Solve. Looks a little nastier, but really it's not. Alright, we know this is a degree 2 equation. And of course what I'm going to do first here is multiply both sides by 15. Of course I don't want to substitute fractional expressions into my quadratic formula, especially if I don't have to. So what I'll do is multiply both sides by positive 15. It does not change my solution set, but gets rid of all the fractions, right? 15 times x squared is 15x squared. 15 times 14 fifteenths, well the 15's cross cancel and end up with a minus 14x equals, and of course on the right the 15's cross cancel, I get 8. Alright, let me get it in standard form. 15x squared minus 14x minus 8 equals 0. Alright, shall we solve? I believe this one does factor. I usually say it like this: if you're given a degree 2 equation, and sometimes factoring is not so easy, sometimes it's harder than the quadratic formula. Depends on the problem. What I say is this: if you think you have a shot at factoring it, go ahead and try to factor it. If it doesn't factor, or it's too difficult to factor, you might be forced to go to the quadratic formula. So it does factor. You can get the answer by factoring here, but we've already done one here like that in this section, so I'm going to ask us to do this with the quadratic formula. It's already standard form, so I'll write down my A, B, and C values and make the substitutions. X equals minus B plus or minus the square root of B squared minus 4 times A times C, be careful of those signs, divided by 2 times A. Looks terrible, but I think I see something happening here. Simplifying, I get a positive 14 plus or minus. If I grind out all this stuff onto the radical sign, it turns into a positive 676 over 30. Now it turns out the square root of 676 is 26. So, well, that makes my life a little easier. So I'll say 14 plus or minus 26 over 30. And it means I have a plus or minus option. 14 plus 26 is 40. Divided by 30 then is 4/3. Or, remember I've got another option here. 14 minus 26 is going to be negative 12 over 30, which reduces to minus 2/5. So here I've got two solutions: x equals 4/3 or minus 2/5. Alright, let's try another one. And again, I'll restrict us to the quadratic formula. Solve by the quadratic formula. And I think factoring works here anyway. X squared over 8 minus x over 4 equals 1 over 2. I suppose it is possible to use fractional coefficients in the quadratic formula, but I'm not going to. I want to multiply both sides by 8. Get rid of those fractions first. You'll have equivalent. solution set. So you end up with x squared. 4 goes in 8 twice, minus 2x in my second slot, and over here on the right hand side 2 goes into 8 4 times, 4. So getting it in standard form, I have x squared minus 2x minus 4 equals 0. Alright, so x equals, well, let me write down what a is 1, right? 1x squared is equivalent to x squared, so a is 1, right? B is minus 2, and C is negative 4. Okay? So x equals minus b plus or minus the square root of b squared minus 4 times a times c, signs please, divided by 2a. It's 2 times 1 down there. Alright, let's see if we can punch this out. Minus minus 2 is 2. Plus or minus 2 squared minus 2 squared is 4. Minus 4 times minus 4 is plus 16. We have a square root of 20. 20 is under that root sign. Over 2 times 1 is 2. Now we've said it twice before. You can't cancel out those 2's. Right, but I can simplify the root and see if I can go further. Well, the square root of 20 is equivalent to 2 times the square root of 5, is it not? And what I can do is factor out a 2 from that numerator, and then I see I've got a common factor of 2 across that fraction bar, and those I can cancel out. So I end up with 1 plus or minus root 5 over 1, or just 1 plus or minus the square root of 5. Again, I'll leave my answer in simplified root form. Okay? Alright, one more and we'll call it a day. It's from your homework list. I believe it's from your homework list. Solve the following degree 2 equation. Now this one may actually be a little simpler than the last one. Of course, I'm going to want to multiply both sides of the equation by 2. And convert to standard form. And I think it's pretty clear that this equation does not factor. So what I can do then is write down a equals 1, b equals 5, and c equals 2. X equals minus b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. X equals minus 5 plus or minus, let's see, 5 squared is 25, minus 8 is going to be 17 under the root sign, over 2 times 1 is 2. Alright, now if I look to simplify, 17 is a prime number and hence contains no factors of any kind, no square factors certainly. So that's it. You're done. X equals minus 5 plus or minus the square root of 17 over 2. This represents 2 solutions in simplified root form. Alright, we'll call it a day. Homework assignments posted in the online folder. We're approaching the 24-minute point. So this concludes section 8.2 Quadratic Formula.